Welcome to HB Tuner's GM Gen 5 training part 9. In this training module, we're going to take a look at the ECM Logic Operation. So this is going to be how the GM Gen 5 engine control module is going to work for both the fuel, airflow, and torque-based modeling. We're going to have a lot to talk about. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look with our Gen 5 applications, doing an overview of the fuel and airflow modeling as well as the torque modeling that we have going on. Now, this is just going to be an overview. We're going to dive into the topics that I bring up in this tutorial in depth in future training modules. So as you're watching this, don't panic if I'm going through things maybe a little bit quicker. We're going to cover things extensively. This is just going to get your brain thinking and your wheels turning to understanding what is going on here, seeing kind of the bigger picture, and then we're going to break down things more specifically so you're able to look at a specific topic very in depth. So first thing I want to talk about here, before we jump in taking a look at any tables or looking at our calibration file here, I want to talk about the underlying fundamental equation we have that's going to be how the fuel and airflow model work. It's a very simplistic equation, but it's very, very powerful. And that's going to be fuel mass is equal to air mass divided by target air fuel. And we'll find this isn't exclusive to GM Gen 5s. This is going to be the underlying equation for any airflow-based modeled system. So whether you're dealing with a Gen 3, Gen 4 GM, even Ford, or looking at maybe imports like a Subaru or even a Honda that's mass airflow based, this is how everything is going to work. We have to understand this concept to move forward into taking a look at things like direct injection, because that hinges upon having the fuel delivered right, which hinges upon having things measured right from our air mass side of things. So let's go break this down of what this actually means. So what we're going to find here is that first and foremost, we need to understand what mass represents. That's going to be the volume times the density. And the way I like to describe this, you understand it as a kind of a physical characteristic, is going to be if we have a cup that's empty, we can calculate the volume of the cup. We fill the cup with water. Well, we know the density of water, we know the volume of the cup, therefore we would know the mass of the cup of water. If we pick up the cup of water, we know what it feels like, it has a certain amount of weight to it, certain amount of mass to it. Now if we take the same cup, it's empty, we have the water out of it, and we fill it with gold. Well, we know the density of gold, we know the volume of the cup, we would know then the mass of that cup filled with gold. And when we pick up that cup of gold, it's going to have a completely different physical characteristic compared to the cup that was filled with water. And that's conceptually what we need to understand moving into understanding what we're talking about in terms of mass, because our equation's talking about fuel mass or air mass. That's something that you probably haven't heard before, so we need to understand what is going on with that. So mass is going to be the volume times the density, and in this case, we're looking at air mass or fuel mass. So let's break this down a little bit further. When we're talking about air mass, we're going to talk about the volume of air entering the engine and then also the density of air. And this is really important because if we're looking at airflow coming into the engine, a lot of people know what CFM means, and CFM is going to be something that we can represent as how much a head flows. So a head flows at this valve lift, this much CFM. More CFM, more airflow coming into the engine is great. But what we're lacking there is describing the full picture of how we're measuring that airflow coming into the engine. That's going to be the density of air, which is really something that's going to be a characteristic of the environment that we're operating our engine in. So for example, if we're taking a look at the density of air at sea level, it's going to be much greater than when we find the density of air at something like 10,000 feet, because we'll have less oxygen molecules packed into that same volume of air from, let's say, the 10,000 feet elevation. If we move down to sea level, we'll have more oxygen molecules packed into that same volume of air. So for the same volume flow of air, so the engine's going to pull in the same amount of volume flow, but the density will be different. And we'll find because the density is different at two different elevations, we have a completely different fueling need or fuel requirement for our engine. We're going to need much less fuel at high elevation compared to at low elevation. So in this situation, we need to be able to characterize how much fuel mass to deliver into the engine, how much fuel the engine's going to need, and the only way we can do that is by characterizing that density aspect and essentially looking at an air mass type of profile for representing the airflow coming into the engine. The volume flow is definitely one thing we need to consider. More air, that's great. but we'll find there is that density that we have to factor in. Now, on top of that, if we take a look at another common factor that can affect density, it's going to be temperature. If we're talking about a cold condition, so a really cold day, let's say it's 30 degrees out, it's wintertime, we're gonna have a lot more oxygen molecules packed into that same volume of air. And if we take a look at, let's say, the same volume of air coming into the engine at 100 degrees ambient temperature, well, we'll find that really hot air has less oxygen molecules. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.